One ring, two rings, three rings. It takes longer to dial the phone.
Hi, Art.
Hey, Bob. First and foremost, could you first explain what is a communication system?
A communication system, in its simplest form, is just a connection or a means by which two pieces of equipment share data. Back in the day, these would be something like a relay that operates and closes based on an alarm condition, or a transducer that generates a current proportional to a measured parameter. Today's systems pack a lot more power than those older systems, and we typically refer to the newer systems as serial communications.
So we have these serial systems in our battery chargers. Tell us very simply, what is it we can do now that we couldn't do then?
Well, I think the big thing, Art, is remote accessibility. You can monitor all the charger's parameters, such as the DC voltage and DC current. You can access and have status to all the alarm conditions. You also have all the control functions available to you. So that means that you can go in and change alarm set points without actually being there.
Okay, so Bob, if I read what you're saying, I can basically control, read, understand, and adjust my battery charger without getting off my butt.
That's correct.
Perfect.
One of the other advantages too, Art, is as we add more and more parameters and more features to the charger, you don't have to add more wires. Anything that you add to the charger, any new features, will automatically become available through the communication system.
So let me ask you this. When it comes to parameters and settings and whatever, maybe give us a little idea as to what it is you really want to make sure as a minimum you measure when you set one of these systems up.
You might want to just start out with DC voltage, DC current, and a few alarms as far as high voltage alarms, low voltage alarms. Later on, as the systems become more advanced, the options are limitless.
Oh, so I can do anything, everything, and I can just look at voltage and current, or I can look at every freaking alarm in the battery charger, and I'm going to get a report in one way or another.
Absolutely.
Wow, that's amazing.
The only thing you really need to know is what connection type you need, whether it's RS-232 or RS-45, and what protocol you want to speak.
So let's talk protocols for a second, because that's another good question. Explain a little bit about what's a protocol and how does it work.
A protocol is a format of rules that's used so that we can each understand what I'm sending or what you're hearing versus what you're sending and what I'm hearing.
We're talking about the computer's language.
Exactly.
And can you tell us what some of the typical ones are that we use?
The three protocols we support are Modbus, DMP, and IEC 61850. Modbus was developed in the 70s by Modicon, which is now Schneider Electric. It's a simple protocol, and it allowed for a simple way for them to share information between their PLCs. It's widely used by the industrial market, and there's plenty of free tools available to simulate both ends of the connection. DMP was developed in the 90s by GE Harris, which is an RTU manufacturer. It's much more complex than Modbus, but it has a lot of extra features and capabilities that are specific for the utility application. IEC 61850, it's a very comprehensive protocol that's supposed to eliminate all interoperability issues between vendors. It meets all the needs and requirements of electrical utilities. It's very robust and complicated, and it's expensive compared to Modbus and DMP. Quite frankly, in my opinion, I don't think 61850 should be implemented in simple devices like batteries, chargers, and meters. I'd recommend, if you want to run that protocol, to get a gateway, which converts that to a simpler protocol like Modbus or DMP.
So here's the thing. Once we figured out the protocol we're going to use, there are different ways of connecting them. Perhaps you can explain some of the ones that are more familiar.
Well, we offer a couple different connection methods. We have Ethernet, RS-45, RS-232, and we also do fiber. Ethernet's rather common. We use it in our office networks, use it to connect our PCs together. The beauty of Ethernet is that there's a lot of devices that can get connected together over vast distances. Ethernet is becoming more popular, but RS-45 is by far, I think, the most widely used connection method. You can connect multiple devices to the same network. The standard network allows you to connect 32 devices. You can actually connect more through other means, but 32 is kind of the limit. RS-232 was designed to connect devices close to your computers, things like mice, or printers, and modems. Typically, that's not really used in the substation other than for configuration purposes. Now, fiber, that's something that can be used with any of the three connection methods I've listed so far. The only difference is instead of having an electrical connection, you have a fiber optic connection. And that's basically sending light pulses down your channel instead of sending electrical pulses.
So now that we've figured out what these communication ports are, then there's another thing called port protocol. So perhaps you can take a moment and explain what that is and how do we assign its parameters and so on.
Well, port and protocol are kind of two different things. The port is the physical connection. Again, whether it's an RS-45 connection or an Ethernet connection, that's typically referred to as a port. The protocol is the language that you speak over that port, things like Modbus or DMP. And the port configuration for a serial port like RS-232 or RS-45, it would be things such as the baud rate, how many stop bits, if you got parity bits. For Ethernet, the port configuration would be things like the IP address, the gateway. The protocol configurations are unique to the protocol. There are things like the address of the device. There's a lot of different means that you can connect via the protocol, and there's a lot of different features that the protocols support, and you can turn those features on or off.
The other thing, Bob, is transmission mode, such as ASCII and RTU. Maybe you could take a moment and explain the differences between those and how they operate as well.
Well, ASCII mode and RTU mode only apply to the Modbus protocol. And ASCII was an earlier version of Modbus that's hardly ever used anymore. When people refer to Modbus, they're typically referring to Modbus RTU. The difference is the amount of data that you can send down the wire. You can send over 2 times as many characters with RTU than you can with ASCII.
So now we know the common thing is RTU. And the other thing that we have is that we can put in both binary and analog pieces of information within our communication system. Can you give us a few typical examples, like what would a binary be and what would an analog example be?
So a binary would be things such as an alarm that can be active or inactive. It could be a particular mode, like equalize mode, on or off. So anything that has 2 states would be considered a binary. As far as an analog, that allows you to represent a range of data, something like a voltage or a current, which could be 10 amps, it could be 6 amps, it could be 3.4 amps. And the protocols handle both of those data types a little differently. Some of the points are read-only, and some are read and writable.
So, Bob, for the longest time, we've heard the term SCADA, which is really the supervisory control and data acquisition system that a utility would use in order to figure out what's going on. So it doesn't just apply to battery charges. SCADA systems can apply to everything. So maybe you could just tell us how our communication systems might relate to a typical SCADA interface.
The SCADA interface is essentially the connection type and also the protocol that you're speaking over the wire. I mean, sometimes it's referred to a network as well. The network is simply just the wire that connects everything together.
Just kind of switching gears a little bit for a second. Question I get a lot is, can I add communications to an old SCR charger? And obviously the answer is no, but maybe you can elaborate as to why the answer is no.
Sure. The SCR charger is an analog charger, which means that it doesn't have a microprocessor or a microcontroller. In order to digitize the information, you need a microcontroller to take the digital value and send it down the wire. So since there's no microprocessor in there, there's no way to convert that analog data into digital data and to send it down a wire.
Okay, so now let's get down to it. What's the short-term stuff that I need to know right off the bat in order to specify communications in my battery charger?
First thing you want to know is the port type. Do you want to communicate via RS-232, via RS-45, or via Ethernet? And then the second thing you would need to know is which protocol you want to speak, Modbus, DMP, or IEC 61850. All you really need to do is specify those 2 things. All of the other configuring that we had talked about is all done via controls inside the charger.
Finally, we've gotten past all of the mysteries behind communications using our battery chargers. Bob, thanks a bunch for being so forward-thinking here, and we really appreciate all the information you gave us.
No problem. It was great talking to you, Art.